All right, you guys, let's get into these flow of energy notes. To start off, we're going to talk about the difference between a food chain and a food web. For a food chain, go ahead and draw a dot with an arrow to a dot with an arrow and a dot to an arrow. And guess what? One more dot. Okay, what a food chain is showing us is the flow of energy from one organism to the next. So this organism's energy is going on to this organism. How did that organism get the energy? They consumed the organism below it. So the energy goes from here to here, here to here, here to here. We have 4 organisms, and that's the energy flow among them. This is different from a food web. For a food web, we still have organisms, so go ahead and throw up some dots on here. These are going to be our different organisms. However, in a food web, these organisms are interconnected. So while we might have the flow of energy going from this organism to this one, this organism might also receive energy from this organism. And then this energy might go here and then there. But wait, maybe there's another organism that's also giving energy there. Maybe this organism also gives energy to that organism. As you can see, it kind of ends up looking a little bit like a spider web, which is why we refer to it as a food web rather than a food chain. This web goes in we're still showing the flow of energy, but they're interconnected, whereas a food chain is just kind of a linear straight line of the flow of energy. So food web, food chain. Moving on to types of energy. You learned about these last class, so we're recapping them. Radiant energy is energy from the sun. Our plants on Earth are going to take in that radiant energy and they're going to convert it to chemical energy. Chemical energy is energy stored in particles of food. So why we always say plants is because the plants are going to take in that radiant energy and store it as glucose. That glucose then can be consumed by other organisms to live out their life processes. Chemical energy is also used by the plant themselves to live out their life processes. So radiant energy, energy from the sun; chemical energy, energy stored in food. Now, us as humans, we're going to take that chemical energy from the plants that we eat or other animals that we eat and convert it into thermal. Thermal energy is generated by an organism and used to perform life functions. So as we're living life, we're using that chemical energy and we're converting it to thermal. Think about your body heat. We're generating this we're converting chemical to thermal as we're doing our stuff. We're eating, we're breathing, we're hunting. All of that, we're releasing that thermal energy. So now that we recap types of energy, we're going to move on down to some examples. Let's start here. So we're going to start with radiant energy, which is energy from the sun. So I'm going to draw a sun. And underneath our sun, I'm going to write radiant energy. This energy is going to go to our plants, but we're not going to just call them plants today. We're going to call them producers. So our producers take in that radiant energy. We're going to draw a picture of a producer. You can choose a different one if you wish. I'm just going to do like a little raspberry bush, or you can do a blueberry bush, or a different type of producer. Can be I'm not picky on that. But here's my little raspberry bush. I'm going to draw in some roots. And like I said, this is an example of a producer. Another name we give producers are autotrophs. And the way I think about autotrophs is that I think about it, they automatically make their glucose or make their energy from using radiant energy. So they get all the energy that they need from that radiant energy. They automatically do that on their own. It's pretty cool. And again, producers, they produce energy for themselves using radiant energy. So that's kind of how I think about it. Where do producers get their energy from? There's going to be 2 different energy transformations with our producers. So go ahead and divide these 2 boxes in 2. And we have a 1 and a 2, and then a 1 and a 2. So let's revisit that question. Where does it get its energy from? Producers are going to get their energy from the sun. And we're going to say that is radiant energy. They're going to get the energy from the sun, and then how does it use it? It converts it. Where's my green? It converts it to chemical energy. So it converts chemical to make glucose. So chemical to make glucose. So to recap, producers are going to take that energy from the sun. Oh, that's what I want to add in. Converts to chemical. I was like, something's wrong. I don't know what it is though. Converts to chemical. There we go. To make glucose. Producers take that radiant energy, convert it to chemical energy, and that's that glucose that they store there. Now, the plant's gone through photosynthesis. It's made that radiant, it's taken that radiant energy and converted it to chemical energy, but now it's still got to go and live its life. So we're going to say that the producers are going to convert that glucose, again, which is chemical energy, and they're going to convert it to thermal. And what are they going to be? Let's rephrase that. So they're going to take that chemical energy, convert it to thermal. They're going to do that as they're just doing their life processes. They're growing, they're going through, maybe they're going through photosynthesis some more, so they got to use energy for that. Maybe they've got a gravitropism going on. Those roots are growing towards gravity. They're just doing their plant thing. So they took the radiant energy, converted it to chemical, and now they're converting that chemical energy into thermal. And those are our producers, otherwise known as our autotrophs. Our next level up on our food chain, draw the arrow, is going to be our primary consumers. So for primary consumer, I'm going to write my title. And I'm going to draw a ladybug. If you have a different primary consumer in mind, that's totally fine. We'll do that. And I'm going to draw in the bottom part. I'm going to give him a little head, some antennae, some legs, and some dots. So there's my primary consumer. Now, this primary consumer is also known as an herbivore. We consider primary consumers herbivores because they exclusively eat producers. So herbivores, there we go. Let's answer these questions for our herbivore. Where does it get its energy from? It gets its energy from producers. So what color do I want to use? Let's use green again. So it gets its energy from producers. And what type of energy does it get from the producers? It gets chemical. And then it's going to convert that chemical energy into, or how does it use energy? It uses it as thermal energy. And it's going to do that as it's eating, moving, flying, whatever else ladybugs do. It's going to use that energy as that. So while our producers went from radiant to chemical and then chemical to thermal, these producers, or this primary consumer is not an autotroph, so it's just going to take that chemical energy and convert it to thermal. It doesn't have that extra radiant to chemical step. It's just chemical to thermal. After we've got our ladybug doing its ladybug things, and then we're going to have another consumer eat that ladybug. So we're going to draw another arrow for our next step in our food chain. And I'm going to do a frog, and we're going to say that this frog eats my primary consumer. And because the frog eats the primary consumer, we call the frog a secondary consumer. And you're going to do your best to draw a frog because they are sometimes tricky to draw. There's no judgment, by the way, on these notes for drawing ability. Just do your best. There's one frog leg, another frog leg, and the final frog leg. There's his belly. Give him some spots. Okay, I'm gonna shade him in green. And he needs an eyeball. Oh, technically two. Two eyes and little nostrils. There's our frog, our secondary consumer. We call the frog a secondary consumer because it consumes the primary consumer. You can think about this as being the first level of consumers and then the second level of consumers. Now, if this frog only eats primary consumers, we would consider it a carnivore. So we're gonna write carnivore. Herbivores eat producers, carnivores eat consumers. Some secondary consumers are considered omnivores. So if this frog not only eats ladybugs, but eats the berries, it would be considered an omnivore, and that would be reflected on the food web where it would have multiple food sources. So maybe ladybug and then raspberries, berries. In a food chain though, we're just kind of drawing a straight line, but just be aware that some secondary consumers can be carnivores if they're only eating consumers, or omnivores if they're eating consumers and producers. So either one. Most humans are omnivores, right? We eat both plants and animals. Okay, so where does our secondary consumer get its energy from? It gets its energy from the primary consumers. And the primary consumers are also going to have chemical energy. So just to kind of recap, we've got our primary consumers, we're getting chemical energy from them going to the secondary consumers. The primary consumers got their chemical energy from the producer. So that's that food chain again. It's showing how the chemical energy is going from the producers to the primary consumers to the secondary consumers. What are the secondary consumers going to do with that energy? They're going to use it as thermal energy again. So for this frog, he's moving around. Maybe he's breathing. Hopefully he's breathing. Jumping around, whatever frogs do, you can write that in there. I just did moving and breathing. And that's how our frog's going to use its energy. On to the next level of our food chain. We have our final level of consumers called tertiary consumers. And in this case, I'm going to do a fox. So I'm going to draw my outline. There's his ears and his legs and paws. Back leg. He kind of looks like the frog, but that's fine. And then there's his tail. And this will make sense in a minute, I promise. To the bottom. Okay. I'm going to add in his nose, nostrils, ears, eyeballs, little tail. Maybe he's got little black fur on his paws. I'll shade him in. All right. So here's my fox. Don't worry, it doesn't look great. Yours doesn't have to look great either. It's fine. Okay, so our fox is our tertiary consumer because it eats our secondary consumer, which is the frog. We will also consider tertiary consumers either carnivores. So if the tertiary consumer only eats consumers, it's a carnivore. If the tertiary consumer eats plants or eats producers and consumers, then again, it's an omnivore. So again, it just depends on what organism it is. But all the same, we've got our tertiary consumer. Where does it get its energy from? It's going to get its energy from the secondary consumer. And that energy is still chemical. That chemical energy just keeps getting passed along through that food chain. How is it going to use that energy? Big shocker. As thermal energy. It's going to be hunting, moving, sleeping, sniffing, whatever that fox needs to do. It's going to be using that energy as that. And then that completes that last box of those notes. So for our food chain, let's recap. For our food chain, for a flow of energy, it all starts with our radiant energy. Our producers are going to get that energy from the sun and convert it into chemical energy in the form of glucose. The process of that is photosynthesis. Then those plants are going to do their plant thing. They're going to take their own glucose, their own chemical energy that they converted, and make it into thermal energy as they're growing and going through their tropisms. Primary consumers consume producers. And so actually, let's take a break from our recap and add the one last thing up here. We need to add in the word that consumer up here. Consumer. So all of these consumers are either going to consume producers or other consumers. Because they're consuming other organisms and they're not making their own chemical energy, they have to consume others to get it. We call those heterotrophs. So we've got our consumers, all the way known as heterotrophs. These guys cannot go through photosynthesis, therefore they cannot go from radiant to chemical. But what they can do is they can consume the chemical energy from the producer. So these primary consumers are going to get their chemical energy from the producers and convert that to thermal as they're doing life processes. And then our secondary consumers consume primary consumers. And as I said, if it's a food web, maybe these secondary consumers also consume producers. It just depends on their adaptations and their food sources. But these guys are going to get chemical energy from the primary consumers and convert that to thermal. And then our tertiary consumers are going to consume our primary, they're going to consume our secondary consumers, and they're going to convert that energy to thermal as well. Now, you may have noticed, Ms. Heim, you wrote thermal, thermal, thermal for all these. Could we also write the word mechanical? We absolutely could have. I just was simplifying it for these. So thermal is giving off of that body heat, but mechanical is the actual movement part. So know that thermal and mechanical are both are the chemical energy. The consumers take in that chemical energy and they can convert it to both thermal and mechanical. So just FYI. All right. Well, I hope you enjoyed your time with me. I've been Ms. Heim. I hope you're having a great day. I think your pictures are great. You did a great job. I'm proud of you. Make sure you're kind to your teacher. We're going to wrap this up. Have a great day. Bye.